Okay, when we're talking trig functions, and we consider a right triangle, then, as you recall, we had sine of this angle alpha equals the opposite side length over the hypotenuse, and the cosine of alpha equals the adjacent side length over the hypotenuse. Well, suppose we do something here and we make the hypotenuse always equal to 1, a length of 1. Then the sine of alpha is just going to equal the opposite over 1 equals just the length of the opposite, and the cosine of alpha equals just the adjacent, or the adjacent over 1. So we can use this idea and go back to a topic we talked about before, the unit circle. So here I've drawn a circle on our Cartesian axis. Now let's assume that I draw a line from the origin to the outside edge. This is the radius, and let's let this be equal to a distance of 1 for the unit circle. That means the radius here is also 1, or the distance from anywhere in the center to the outside edge is 1. Well, then we can define our trigonometric functions in such a way. So say this is our angle alpha. This is then, since this is 1, alpha equals just the opposite. Which equals sine of alpha. So this distance here equals sine of alpha. That's this distance here. And this distance here is going to equal the cosine of alpha. Well, you can imagine as we spin this radius from alpha equals 0 out to alpha equals 90 degrees, what's going to happen is this sine of alpha is going to grow and the cosine of alpha is going to shrink. But really, what we have here is a situation where whatever point we have, x, y, any x value, any y value, is going to equal cosine of alpha, sine of alpha. So we could say that x equals cosine of alpha, or the value of x equals cosine of alpha, and the value of y equals sine of alpha. Let's say that alpha equals 60 degrees if we draw the triangle over there. So it looks right. So this distance, this angle is 60 degrees. Well, the cosine of alpha then is going to be equal to 1/2. So cosine of alpha equals 1/2, which is the value of x here, 1/2. So it's half the circle. This looks a little over half, but really it should only be half the circle. And then the sine is actually going to be equal to square root of 3 over 2. The distance is square root of 3 over 2. So the sine of alpha equals square root of 3 over 2. And this equals the distance of y. What if I change it around? I make alpha equals 30 degrees. Well, that means our triangle is going to change shape a little bit. So So now it's going to look like this red line, this red triangle here, and essentially it's just turning this triangle around. Now this edge is equal to, so now the sine of alpha still equals the value of x, but now this x value is only 1/2 the distance up here, which is 1/2 of 1. And cosine alpha is, sine alpha is still y, not x. Got these backwards. That never changes. Sine alpha is y. Cosine alpha is the length of x, which is now square root of 3 over 2. Okay? So I always start my angle on the positive x-axis. That's my initial point. And my terminus, then the angle is between that and the terminal line. Let's say I want to do this. I want to come over here. So this is quadrant 1. I want to come over here and do this angle. Let's call this beta. So now I'm in quadrant 2. I was in quadrant 1 before. The same thing is going to hold. Except now, the x value, so we need to plot this coordinate. The x value here is 1/2, and the y value, or the distance from here to here, is square root of 3 over 2 still. So it's a mirror image of this. So x equals 1/2. But it's a negative. This is a negative 1/2 because we're heading in the negative direction now. So the cosine of 120 degrees is equals x equals minus 1/2. Still equals x, the x value, but equals minus 1/2. And the sine of beta, or the sine of 120 degrees, is going to be the same as the sine of 60 degrees, and that's going to be equal to square root of 3 over 2. Now I can go another 60 degrees, and notice at this point, I'll do it in green. Well, green's a bad color. I'll do it in orange. At this point now, when I go 180 degrees, so we're going from here to here, let's call it theta. Theta equals 180 degrees. Now, the sine of theta still equals y, but what's the value of y? It's 0. And that's the sine of 180 degrees. Cosine of 180 degrees equals x. And what's this value? This total value here is what? It's 1, value 1. So this is a really clever way to remember what your periodic functions are as you go around the circle. And once you repeat, the values all start again. So we could continue. I'll do one more. So here, now the angle I still start from this x point here. I spin around this way. Now this is 180 plus 60, which is 240. So if I spin around 240 to the red line here, start at the green and spin around 240 to the red line, now we're in quadrant 3. Notice now that both the x and the y value are negative. So this is minus 1/2 still. I guess I'll do it in red. Minus 1/2 for an x value, and the y value is minus square root of 3 over 2. So the sine of 240 degrees equals the y value equals minus square root of 3 over 2, and the cosine of 240 degrees equals the x value equals minus 1/2. Let's check this with our calculator. 240 degrees, so I'm in degrees here, and I'm going to take cosine of this, minus 1/2. 240, let's do it again. I'll take the sine of this, and it's minus 0.866, or square root of 3 over 2. So that's how we handle 30-degree increments and 60-degree increments. We could also, let's look at other angles. Let's look at 45 degrees. Let's say alpha equals 45 degrees. So 45 degrees, that's halfway between 90. So 90 is straight up and down. So that's halfway between a 90-degree angle. That means that y is going to be actually equal to x. These sides are going to be the same length. So this will actually be 45 degrees up here too, on this angle. Well, I can take this angle and look at this, and we can investigate it. And using Pythagorean's theorem, I see that x squared plus y squared equals 1. But then again, I mentioned that y was the same as x, so x squared plus x squared equals 1 equals 2x squared. So x squared equals 1/2, or the square root of x equals the square root of 1 over the square root of 2. So it's usually better to write this as it's 1 over square root of 2, and then if we multiply it by 1, or square root of 2 over 2, we get that x equals the square root of 2 over 2. So the square root of 2 over 2 is the same thing as 1 over square root of 2. It's just written differently. Well, we said y is the same, so y also equals the square root of 2 over 2. So here's the coordinate then for this point, square root of 2 over square root of 2, and that means that, so then in summary, here are the values of our trigonometric functions, common trigonometric functions in the first quadrant. For 0 degrees, we have x equals 1, y equals 0. For 30 degrees, we got square root of 2, square root of 3 over 2, and 1/2. And 45 is square root of 2 over 2. 60 degrees is 1/2 for x, square root of 3 over 2. And 90 degrees is 0 and 1. And again, this is our angle here. It just gets bigger and bigger and bigger.